Hello everyone. This is Sethu Srinivasan AN from Beltech Multitech Dr.Rangarajan. Our final year project topic is solar enhanced dual battery dynamics, revolutionizing the vehicle energy management, temperature monitoring. The contents displayed in this project are objective, introduction, problem statement, literature review, references from literature review, existing system, proposed methodology. Objective. The first objective is to overcome the travel interruption at some random place due to battery draining by providing a battery backup powered by solar panel. Let's say a person is traveling from point A to point B, which is nearly 300 kilometers apart, and the vehicle is stopped at some random place where facilities are not enough. In that case, uh, the passengers will be facing some issues. That issue should be overcome. Then the second objective is to overcome the battery blast due to excessive heating. Normally, a battery provides some loss of energy in form of fuel. But due to excessive heat, there is a possibility of battery explosion. Uh, this may cause danger to human lives. This issue should also be overcome. The third objective is to update the location of the vehicle for seeking a battery drains. Uh, if some battery drains out at some random location, uh, the user will be finding difficult to seek help. In that case, there is no such facility to send some location to for some assistance. This is the third objective. Introduction. The most recent decade, there are two critical issues developed in burning of vitality all through the world. The first one is limited petroleum in the near future. Second one is carbon discharge result in a worldwide temperature alteration. Limited petroleum in the near future. Uh, the petroleum is a non-renewable resource. It is limited. The cost is also increasing due to its limitations. Then the carbon discharge from the vehicle uh, also causes some increase in global temperature, causes global warming. So it is a greenhouse gas which may also cause greenhouse effect. Then there's a possibility of depletion of ozone layer. Non-renewable energy sources are non-sustainable. They draw on restricted assets which will within the future diminish, turning into expensive or too earth warming, creating it not possible to recover. Therefore, renewable energy like solar energy is a sound solution to this problem. An electric vehicle may come to sudden stop unexpectedly due to battery. If a battery gets depleted at some random place, uh, then the vehicle will be stopping suddenly, irrespective of the location. Then the battery explosion will also occur due to overheating, which may cause a danger to human life. If an electric vehicle stops in some unfamiliar location due to low battery, there is no such case for assistance. These are the three problem statements covered in this project. These are the literature. These are the journals referred in the year of 2022, and the inferences obtained from literature review are building an automatic system for prospering a rechargeable battery supervision scheme, blockchain implementation of EV battery management system, building a swapping technology for providing solution to accomplish interstate outing. Existing system. The current infrastructure for electric vehicle charging predominantly lies on stationary charging stations where EVs connect to the grid for an extended period to replenish their batteries. This system often leads to long wait times, especially during peak hours, and can be inconvenient for drivers, particularly for those on long journeys. This is the issue faced by passengers on electric vehicles like New Go, where the vehicle will be uh, charge will be put for charge for nearly 1 hour and the passengers should stay without AC in that case. So this is the issue faced by the passengers and the driver too. Moreover, the range anxiety associated with EVs limit their widespread adoption. In our existing system, the feasibility to monitor the battery performance gives intimation to the user when it is drained. It does not present any automatic solution to replace the battery without any human interface. Uh, the system is also not capable of emergency information updating. That is, if a battery drains out, then the human should get down, get the drained battery from the battery hole, replace it with a charged battery, then should get back and drive the vehicle. There is no such kind of automatic battery replacement system, and then the system is also not capable of updating information to cloud in the existing system. So the proposed methodology, here we are using two batteries. One is a main battery and other one is a backup battery. Both will be connected in parallel to each other. If one battery gets completely, if the main battery gets completely drained out, uh, the main battery gets completely drained out, then the secondary battery will be coming. Uh, when secondary battery uh, runs the motor, the primary battery will be charging through the solar panels. In that case, human need not get down and change the battery from primary to secondary. We uh, will be executing it automatically through relays. The relay which is used in this case is Form C relay. It is a single pole and double throw. So using the relays, we can energize the coil and we can uh, connect the battery and charge the other battery accordingly. And then the temperature sensor is also there. Uh, we have seen that due to excessive heat in and around the battery, battery explosion occurs, which may cause danger to human life. We are introducing some temperature sensor on each batteries, such that if temperature goes beyond 33 degrees Celsius as its threshold value, then the buzzer alarm will be given. At that time, the vehicle driver should let the engine and battery cool. Once the temperature cools down, should take the vehicle again. This will prevent the life of uh, human as well as uh, the life of some components, batteries, etc. In order to overcome the existing impacts, we designed an intelligent prototype module for battery management system of electric. At the core of this prototype module is an compact electronics unit comprising essential components such as microcontroller. The microcontroller which is used here is of a ESP32 microcontroller, which contains some Wi-Fi modules in its architecture, and then power supply, batteries, solar panel, voltage sensors. The voltage sensors are of two in numbers. Battery is also two in numbers. The relay is also two in numbers. As I mentioned, that there is a Form C relay, then which is of single pole and double throw. Motor will be there in IoT modules. By using voltage sensor, we can monitor the voltage level of batteries. By using temperature sensor, we can monitor the temperature of the temperature goes beyond threshold value, that is 33 degrees Celsius. Buzzer alarm will be. Sorry. Uh, these are the things I mentioned earlier. EV contains two batteries. The system will use backup battery by relay. Solar panel is used for charging the backup battery. But this is the case which we are not discussed, here. If two batteries get drained out, let's say both the batteries are drained out in this scenario, then what will happen? Then the location will be updated in the portal, uh, which which can be managed and used for assistance. Uh, if the vehicle uh, is stopped at location A due to battery drain, due to drainage of both the batteries. Then the location of the place where the vehicle stopped, the latitude and longitude of the specific location will be updated in the portal, and the manage the person who is managing the website can send some person for assistance. The integrated system will enable seamless communication and coordination between the various components, ensuring efficient operation and management of the EV's batteries. The intelligent prototype module for EV battery management represents a significant advancement in the field, offering comprehensive monitoring, control, and safety features. This is the block diagram. It consists of power supply, a temperature sensor, two voltage sensors, two battery, one solar panel, and IoT, followed by relay and a motor. Result and discussion. The system design phase is an extensive process that involves a thorough analysis of each component, including the ESP32 microcontroller, fuel battery system, solar panels, Wi-Fi module, temperature sensor. The integration of real-time monitoring and alerting mechanisms has empowered users with actionable insights, enabling proactive management of the electronic system. Battery will automatically be switched to the other one if one is drained by using it. The status of batteries will be continuously updated. This is the portal which is managed by the person who is managing the vehicle. In the worst case, if both batteries drain, location of the vehicle will be sent for assistance, which is updated. The data from temperature and voltage sensors will continuously monitored and updated in the ESP30. Temperature value exceeds 33 degrees Celsius, as I mentioned here. It should let the vehicle should be stopped for inspections. It is indicated through alarm. This is the final page of the portal in which data is updated continuously. It consists of battery 1 voltage, battery 2 voltage, operation status, temperature status, location, and date and time at which these data are collected. The live demonstration of the project. The practical demonstration of the project is arranged for setup. Before diving into the demonstration, let's see about the circuit of how it works. This is the circuit. As I mentioned that there are two batteries. This one is the first battery and the second battery. This is considered as primary battery. And this is considered as secondary battery. The primary battery will be given serial communication to a relay. This is a relay module, that is a relay component. The battery will be serially connected to the relay and it is given to load connections. It is also connected with voltmeter, then it is given to load. Here load is nothing but ESP32 microcontroller, then capacitors, inductors, PN junction diodes, resistors, etc. What happens is, if the circuit is serially connected, then the electrons will be the conventional current will flow from positive terminal of the battery to the negative terminal of the battery, and hence the motor will run. The main part of the load is a motor. Okay, let's say I am connecting motor here. Then the motor will be running here. As electrons are flowing from positive terminal to the negative terminal of the battery, the motor will be running. What will happen here? The electrons will also flow here to here, then here to here. But the electrons will not flow from here to here because of open loop. The circuit is not closed. It is because of
the relay. What happens is the electrons which are flowing through this path will energize the coil. What happens is the coil which is energized will generate a magnetic field which will keep the relay as normally open and will prevent it from getting closed. And that's why there will be open circuit here. Then the temperature, the voltage will be given to temperature sensor. Then the normally open path will be connected to solar panel. Okay. What happens is this battery is not connected to this electron flow. When the battery, this is the primary battery, motor is running through it. The secondary battery is kept as a backup battery. Once the battery is completely drained from this, then the secondary battery will comes into play. How it occurs is if the battery is completely drained, then this NC connection will become NO connection, because coil will not energize here, so it will be becoming NO connection. As electrons are not flowing from here to here, then this coil will also not be energized, and it will also change from normally open to normally closed. As a result, the circuit connection will be established in this loop, and that's why the voltage will flow from this battery. What happens is then this battery will be connected to solar panel, from where it will be charged. So the main concept here is the battery if this battery is used to run the motor, and then this battery will be a backup, and it will be charged in the back end through the solar panel. We are also having a voltmeter to sense the voltage, and temperature sensor to sense the temperature of each battery. And then we will be having a buzzer also. A buzzer will also be there. The threshold value of the buzzer is the threshold value for the temperature sensor is of 33 degrees Celsius. If it goes beyond that, the buzzer will be giving some alarm or alert. Then the main part of the load is ESP32 microcontroller. What happens is the data fetched, the voltmeter data, the buzzer data fetched, temperature, the data fetched will be updated continuously to the portal, to the IoT begin portal. If both batteries are completely drained, then the latitude and longitudinal location of the module will be sent to the portal. It will also be demonstrated here. Okay, this is a circuit flow. Let's see how it works. This is the portal which I already mentioned, iotbeginner.com. The username is iotbegin048 and the password is also the same. I have logged in, and then I have given view IoT data. Here the time now is 8:28. At 8:28 both batteries are empty. The circuit is here. Both batteries are not connected. The negative terminal of both the batteries are not connected, and that's why the status shows that both batteries are empty. Okay. If both batteries are empty, the latitudinal and longitudinal location of the module, the vehicle, will be sent to the portal, which can be seen here. The temperature sensor senses the temperature, which is a normal temperature, around room temperature, and then the date and time will also be updated. Let's see other two cases. Okay, what happens if both the batteries are connected? I am connecting this battery right now. Both the batteries. What happens is I'm connecting both the batteries. I'm refreshing the data. and the time now is 8:29 8:29:17, operated by battery 1. Battery 1 voltage is 12 volt and battery 2 voltage is 12 volt, and the motor is run by battery 1. The temperature is since it is normal. If some battery is operated to run the motor, there is no need to share the location. Only in the case of both the batteries drained out, we will be updating the latitudinal and longitudinal location of the prototype module. What will happen if any one of these is removed? Let's say I am removing this. It is still running the same, which means that this is battery 1. So when I remove battery 2, there is no change in operating status of the prototype module. So this is battery 2. If I remove the battery 2, nothing happens. What will happen if I remove battery 1? I removed battery 1. What happened is voltage 1 becomes 0. Voltage 1 becomes 0, and then voltage 2 becomes 12 volt. So from this 12 volt is fetched and the motor is run through it. I am connecting this, and then I am disconnecting this. While disconnecting battery 2, here battery 2 voltage will be shown as 0 volt. The same can be seen here also. It is now operated by battery 1. You can see here. It is now operated by battery 1, as this is a battery 1, this is battery 2. Both the terminals of battery 1 are connected. So it is operated by battery 1. Battery 2 voltage is 0 volt. Temperature is normal. I am connecting this, and I am removing this. Then the relay is switched. Then I am refreshing this. It is operated by battery 2. You can see here. Sorry. It is operated by battery 2. Temperature is normal. So this is the flow of this circuit, and this is how it works. Thank you.